Hi, my name is Yan, and I'm a member of the Teen Advisory Board with the Howard County Library System, and today we'll be going over partial fraction and decomposition. Alright, and what we mean by this is it's the process of taking apart a simplified answer and returning it to its initial expression. So I'm sure we're all used to adding and subtracting fractions by multiplying by the denominator and then just combining like terms. But instead of following the green arrows right here, we're going to actually look at the final answer first, and we're going to take it the reverse process, and we are going to separate it into the two initial fractions, or three. It does not matter, as long as we're taking apart the final answer. So, to start, let's look at an example. Find the partial fraction decomposition of 3x plus 10 over x squared plus 9x plus 20. So, our first step is always to factor the denominator. The numerator stays the same, so the numerator stays 3x plus 10, and our denominator becomes x plus 4 times x plus 5. All right, so now that we have that, we have to set up the expression so that each factor becomes the denominator of its own individual fraction. So what I mean by this is now currently we have one whole fraction. What we want to do is we want to make x plus 4 its own denominator in its own fraction, and x plus 5 as the denominator in its own fraction as well. So the way we set it up, we have x plus 4 here and x plus 5 here. You'll notice that we don't know the value of the numerator yet, so we assign the values with a and b. So a and b we'll later solve for. So speaking of which, solving for a is our third step, and what we're going to do is we have to find a value for x that will make the denominator equal to 0, and we are only looking at this partial fraction, so this one. This is the only one we're looking at because a is the numerator of this fraction and not the other one. So we set x plus 4 equal to 0, and we would get that x equals negative 4. Now, our next step is to substitute this value into the factored expression from step 1, which is this expression right here. And it's important that we ignore the factor that we are currently solving for. So if you notice, x plus 4 is the original factor in our new partial fraction. So what we do when we're substituting and solving for the value of a is we can substitute negative 4 into the numerator right here, and the denominator, but only one factor of it. We will be ignoring the x plus 4, okay? Because that's the denominator in our fraction. And this is where we'll get our answer. So 3 times negative 4 plus 10 over negative 4 plus 5. All right. And then we'll get negative 12 plus 10 over 1, which is just negative 2. And that is going to be our value for a. A equals negative 2. All right, we repeat this process for b as well. So instead of looking at a over x plus 4, we're going to look at b over x plus 5. And this is going to be our partial fraction that we're going to use. We set the denominator equal to 0 again, and then we get that x equals negative 5. And again, we substitute that value into the factored expression. Except this time, instead of hiding x plus 4, we're going to hide x plus 5 because x plus 5 is in the denominator of our partial fraction. So when we solve for this, we get 3 times negative 5 plus 10 over negative 5 plus 4. So this gives us negative 15 plus 10 over negative 1, which is just negative 5 over negative 1, which just equals 5. So that's our value for b. Okay? So now that we have both the a and b values, our final step is to substitute a and b into their respective partial fractions. So we know that a equals negative 2, so we substitute that in. So we get negative 2 over x plus 4 plus, we know that b equals 5, so we substitute 5 in for b here. We got 5 over x plus 5. And this will be our final decomposition. That's going to be our final answer. Also, it's really important to notice how the power of the expression in the numerator, so 3x plus 10, that is linear. So it's to a power of 1. So it's x to the first power. And notice how the power of the expression in the denominator is x squared. It's x squared. So what's important here is that the numerator's power is less than that of the denominator, and that is the rule for which we can use partial fraction decomposition. It cannot be possible if our numerator's power is greater than that of the denominator, and we're going to see a problem like this next. So, looking at our new problem, we see that we're trying to find the partial fraction decomposition of 2x cubed plus x squared minus 7x plus 7 over x squared plus x minus 2. Now, immediately we see that 2x cubed, the power, which is x cubed, is greater than that of the power of x squared. All right, so that means the power of our numerator is greater than the power of our denominator. And remember how we want the numerator's power to be less than the denominator? In order to do this, we need to take an extra step in order to achieve this result. And also, this extra step, which is long division, can also be used when the numerator's power is equal to the denominator. This is when we use long division for these two conditions. So then our first step is to just long divide. I hope everybody remembers how to long divide. I'm not going to detail over it, but 2x, we want to get x squared to equal 2x cubed, and that's how we're going to do it. We're going to multiply everything by 2x. So 2x cubed plus 2x squared minus 4x plus 0. Then subtract everything, and then we should get negative x squared minus 3x plus 7. And then we're going to find a way to get x squared to equal negative x squared. So we multiply everything by negative 1, and we should get negative x squared minus x plus 2. Then we subtract everything. So this becomes 5, and this becomes negative 2x. All right, so now if we remember when we divide by polynomials, this expression right here becomes part of our remainder. So it would become, our remainder would equal this value, so negative 2x plus 5 over our original denominator, which is x squared plus x minus 2. All right, so now we can rewrite the original expression as 2x minus 1, which comes from here. So 2x minus 1 plus the remainder. So the remainder is here. So this is the remainder. All right. Now, that is the only additional step to solving problems where the numerator is greater than or equal to the denominator, the power, that is. So all the following steps are the exact same, except we only apply these steps to the remainder, which you'll notice the numerator is linear and the denominator is quadratic. So this means that we can now use partial fraction decomposition. And when we do, we use the same steps. So we factor first, and this will give us this expression right here. And then we have to set it up. So x plus 2 times x minus 1 becomes 2 separate fractions. And then now we just have to solve for a. So let's use a first. Let's solve for a. So set x equal to 0. So we get let x equals negative 2. And then we substitute it in. So negative 2 times negative 2 plus 5. So remember, we're using this partial fraction, and x plus 2 is the factor. So we're going to ignore x plus 2 when we're substituting. Over over negative 2 minus 1. All right. When we do that, we get 4 plus 5, so 9 over negative 3 equals negative 3. And that is going to be our value for a, equals negative 3. All right. Now, solving for b, we're using the second partial fraction. We set it equal to 0, so x minus 1 equals 0, sorry. And then we get x equals 1. And then we substitute 1 in for this expression here, except this time, because we're looking at because we're looking at this partial fraction now, we can ignore the x minus 1 in the denominator. So we get negative 2 times 1 plus 5 over 1 plus 2. Alright, so that gives us negative 2 plus 5, so that's 3 over 3 equal 1. So that is going to be our final value. We know that a equals negative 3 and b equals 1, so all we have to do is plug these values in for a and b. So looking down here, we get that 2x cubed plus x squared minus 7x plus 7 over x squared plus x minus 2 equals 2x minus 1 minus 3, because that's the value of a. Actually, I should probably switch up the color for a little bit. Alright, we get that a equals negative 3, so we get 2x minus 1 minus 3 over x plus 2. Okay, so that's what we get here, right? And we get plus 1 over x minus 1, because that is where we get this. And that should be our final answer. All right. That's also where we're going to end off for today. I hope that you found this video useful, and thank you for watching.